Assalamualaikum and hello everyone. Welcome to the video for 4.2 functional group and homologous series. In this video, we will learn to define functional group, state the functional group, identify functional group in a given compound, define homologous series, and explain the general characteristic of homologous series. Okay, so without further ado, let's look for the definition. So, functional group is an atom or group of atoms in an organic molecule which characterize the molecule and enables it to react in specific ways which determine its chemical properties. So actually this is definition, but actually what we're going to learn further about the functional group is the examples of the functional group present in your organic compound. So which we're going to learn for the rest of our semester 2. Okay, so that's the definition for functional group. So what's the definition for homologous series? It is a series of compounds whereby each member differ from the next member by a constant CH2 unit, where all the members are represented by the same general formula. For example, if your homologous series is alkane, it will follow the formula of CnH2n plus 2. But for alkene, it will follow the general formula of CnH2n. Okay, here it mentioned that all the members will have the same functional group and the same chemical properties. So if it has the same homologous series, it will have the same functional group. Okay, the successive members of any homologous series differ by a CH2 unit. Okay, so for example, you have your propane. Propane is actually when your carbon is 3. For example, you have CH3, CH2, CH3. Okay, successive is actually one next to one another kan, macam tu. Butane, so butane is actually when 4 lah. So what is the general formula? CH3, CH2, CH2, CH3. So as you can see, the difference is actually when you add one more, so you're going to add CH2. The difference is actually adding one more CH2. If you have your pentane, it's 5. Pentane 5, it has CH3, CH2, 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 CH3. So you're adding one more CH2 unit. Okay, and then there is a gradual change in the physical properties with increasing number of carbon atoms, which we will be discussing later lah, when we learn about specifically about your functional group. Okay, so that is actually the definition. So without further ado, let's look for the examples. Okay, so homologous series is the term that we're familiar with, but then for the rest of our organic chemistry, usually we will look at in terms of functional group. Okay, so first let's look for the alkane. Okay, alkane, it does not have any functional group, so that's why it dash dash. That is your alkane lah. Okay, next is your alkene. Alkene is where your carbon-carbon double bond. You have carbon is double bonded to each other, and the name of the functional group is the carbon-carbon double bond. Okay, next is alkyne. Alkyne is where there is a triple bond between the carbon itself. So the name of the functional group is carbon-carbon triple bond. And here is the examples. Okay, next homologous series is alcohol. So I believe you're familiar with alcohol. Okay, when we talk, this is COH, but actually that is the name of homologous series. The functional group for alcohol is hydroxyl, where OH must be bonded to your carbon. Okay, next is arene. Arene is actually where you have your hexagon and you have your alternating double bond. It means that you have double bond, single bond, double bond, single bond, double bond, single bond. Or you could also draw it in terms of hexagon, and then you're going to draw a circle inside of your hexagon. Okay, the name of the functional group is benzene ring. Okay, next we're going to look at is phenol. Okay, so for the case of phenol, it has the same case of our benzene ring, where we have our benzene ring where hexagon, and we have our double bond, single bond, double bond, single bond, double bond, single bond. Okay, the difference is that for the phenol, you will have OH directly bonded to your benzene ring. Okay, so the name of the functional group is phenol as well, but then let's look for this example here. Okay, so here I have my benzene ring. Because how do I know it's a benzene ring? Because I have my double bond, single bond, double bond, single bond, double bond, single bond. So here is your benzene ring. Okay, here we have our OH, but OH here is bonded to the carbon. So it's not a phenol, because phenol is when OH directly bonded to your benzene ring. So here is actually it's not alcohol, this is my hydroxyl. Mostly we're going to discuss about the functional group is hydroxyl for the alcohol here. Okay, the same goes here. Okay, as we can see, the OH is directly bonded to the hexagon. But is the hexagon benzene ring? Okay, benzene ring, remember we need to have the alternating double and single bond. But then here is actually a cyclic structure lah. This is cyclic hexanol. So this is actually our hydroxyl as well. So just for phenol, make sure the OH is directly bonded to the benzene ring. Okay. So that is the examples on page 4. On page 5 here, first we have homologous series is haloalkane. So haloalkane is actually originally from our alkane. Okay, but then how about the haloalkane? Is that one of the hydrogen will be substituted with halogen. Halo ni halogen lah. Halogen is actually element from group 17. It could be fluorine, chlorine, bromine, iodine. Okay, so that's why here we have C, and carbon tu is bonded to your halogen. And the name of the functional group is halogen. Okay, next is ether. So for the case of ether, you need to have your carbon, oxygen, carbon. Okay, remember that for the oxygen itself, you need to have 2 covalent bond, and actually we have 2 lone pair here. But if you don't want to show it, it's fine. But then here is ether, COC. The name of the functional group is alkoxy. Next is aldehyde. Aldehyde is where your C is bonded to double bond O, but then for the aldehyde you have your hydrogen bonded to C double bond O here. And the name of the functional group is carbonate. Here is the examples. Next is ketone. Ketone is where you have C double bond O again, but then instead of hydrogen, the carbon double bond O is bonded to Arni. It's any alkyl group lah. Arni, it could be, I'm just going to draw at the side here. R2, it could be CH2, it could be CH2CH3, any alkyl group. Okay, if you're not familiar, what is alkyl group? Okay, no worries. Later we're going to look at it during chapter 590. So, R2, it means any carbon lah, any alkyl group. Assume any carbon kita. Okay, so for the case of aldehyde, the carbon double bond O must be bonded. One of it is hydrogen. Okay, for the carbon, for the ketone, is the C double bond O, but it must be bonded to both carbon. It can't be one of it is hydrogen. If one of it is hydrogen, it must be an aldehyde. Okay, but then the functional group is the same as aldehyde, where is the functional group is carbonyl. Okay, for this case, aldehyde and ketone, the homologous series is different, but then the functional group is the same because we have C double bond O. And here is the examples. Okay, next is carboxylic acid, which is your homologous series, where we have C double bond O, and then on the same carbon we have OH. The name of the functional group is carboxyl. Next is ester. So ester, okay, it's the same as our carboxylic acid, but the difference is that instead of H here, what we're going to do is actually we're going to substitute the H with R. R again, senang assume saja it will be your carbon lah. So the COC, but then it has extra double bond O on your carbon. So the name of the functional group is carboalkoxy. So that's why kalau kita tengok carboalkoxy dengan alkoxy ni kan, why? Because here is COC, here pun COC. But then for the carbo ni, it means that on the carbon you have your double bond O. Remember yang carbo ni ada C double bond O, C double bond O, C double bond O. Okay, next is actually acyl chloride. So for the acyl chloride, okay, we're going to compare carboxylic acid dengan acyl chloride ni lah. Instead of OH, we're going to substitute the OH with Cl. So that's why we call it as acyl chloride. And the name of the functional group is acyl chloride as well. And here is the examples. Next is amide. So amide, so here we have C double bond O. Here we have C double bond O as well. But then instead of Cl, here we have NH2. Okay, why NH2? not NH3, because actually when we add NH2, then your nitrogen will have 3 bonds and 1 lone pair, which this is actually the structure that the nitrogen wants, so that the formal charge will be equal to 0. So the name of the functional group is carbosemide. Carbo again because your C double bond O. Okay, and then carbosemide must be the NH2 bonded to your C double bond O. Next is amine. Okay, here for the amine, we still have NH2, but this case around, the N is bonded to your carbon. Any carbon lah. Kalau carbon tu bonded to double bond O is carbosemide. But then if the nitrogen is bonded to carbon, carbon that is not bonded, carbon yang bonded, that is not bonded to oxygen, we call it as amino. Here's the examples. And the last one is nitrile. Okay, nitrile is where the carbon has triple bond with nitrogen. For the case of alkyne here, carbon is triple bonded to another carbon. For the nitrile, the carbon is triple bonded to the nitrogen. And the carbon must be bonded to another carbon juga. But then the functional group is cyano. So that's quite a lot of the functional group that we have learned. Okay, it seems quite a lot, tapi no worries. I believe nanti by the end of semester tu, some of it will be familiar lah, because most of the reaction we will learn in detail lagi. Next, what we're going to look at is for the examples itself. So, it's on page 6. So here, let's look. Redraw the structure in expanded form and name the functional group present in the compound. Okay, so for the examples here, I'm going to do just 3 together. But then first, let's look for the functional group lah. Okay, so first example A. So what is actually the functional group? Okay, yang kita nampak lain sikit here is actually here. We have our double bond here. So what I'm going to do is actually first I'm going to circle this one. Okay, and then I'm just going to check back again. What is the name of the functional group? Okay, we know that double bond ni alkene kan? But then what is the functional group? Alkene ni, the functional group is carbon-carbon double bond. So I'm just going to write, it's a carbon-carbon double bond. Okay, make sure you write it down as this one. Jangan write down dia macam C double bond. Tu kira salah. You have to write down the full name of it. Carbon-carbon double bond. Okay. But then, actually, the question first asks you to redraw the structure in expanded form. Okay, so let's do it together. So for the skeletal structure, if you're a bit unsure, it's fine if you number it. So here I'm just going to number 1, 2, 3, 4, 5. So it means that on a straight chain, I will have 5 carbon. So 1, 2, 3, 4, 5. Okay, but then on carbon number 2, I have another 1, 2 carbon, kan? I'm going to label carbon A, carbon B. So I'm just going to use a different color. So on carbon number 2 here, we have 1, 2, here my carbon, here my carbon. Okay, so this is the structure. But then apa lagi? Remember between 4 and 5 we have our double bond here. So double bond. Okay, so how to draw it? Remember that carbon needs to have 4 bonds. Make sure 4 bonds. So what I'm going to do here baru 1, so 2, 3, 4. Here pun, the purple one only got 1, so 1, 2, 3, 4. So make sure, check one by one, does the carbon have 4 bonds? If not, we're going to add the lung in there. Okay, just check it again, remember, okay, actually for the case of double bond ni lah, make sure here 1, 2, 3, 4 for this carbon. This carbon 1, 2, 3, 4. Remember carbon 4 bond only. Kalau 5 salah. Just check it again. So what should we do next? Okay, even though kalau kamu macam ni memang salah lah. Actually you need to show your hydrogen as well. So this is actually the structure. Okay, example B ni you try yourself. Tapi the functional group tu nanti please answer the Google form. So let's do for example C. Example C ni nampak lain lah. You have your oxygen in the middle here. Okay, so what we're going to do is actually, first thing first, check the functional group present. So, functional group present yang ada oxygen. But then here, what does it mean? Kat sini is actually we have our carbon and carbon, kan? So, when we have our carbon here, maknanya kita ada COC. So, COC, what is the functional group? COC, the functional group is actually alkoxy. So, what I'm going to do is actually I'm going to circle and label it as alkoxy. Next, let's draw it. Okay, so label it carbon number 1, carbon number 2. So this is not a carbon. Number 3 ni is actually here is oxygen. Okay, and then after the oxygen, carbon number 3, carbon number 4. So I'm going to draw it. 1, 2. Okay, next to carbon number 2 is actually our oxygen. Next to the oxygen is our carbon number 3, carbon number 4. Remember, carbon need 4 bonds. So make sure we have 4 bonds lah. Okay, but then how about the oxygen? Oxygen actually ada 2 covalent bond and 2 lone pair. So, draw je lah dia punya lone pair here. Okay, so how about the rest of it? We're going to fill out with hydrogen. So this is the examples. Okay, I believe the rest you could try yourself. It's just that, just to remind you, for the case of, especially the benzene kan, make sure carbon tu ada 4 bond. So contohnya F ni, just this one. I'm just going to show it to you. For example, here is my expanded kan. Here carbon, 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 carbon. So for the carbon here, for the first one ni, carbon ni baru ada 1, 2, 3. So it means that it needs 1 more bond. This carbon, this carbon 1, 2, 3, 4. Enough. So this carbon 1, 2, 3, 4. Enough. This carbon 1, 2, 3. So we need 1. This carbon 1, 2, 3. So we need another one. This carbon, count 1, 2, 3. So it means that we need another one. So the one yang ini, hydrogen, 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 hydrogen. Remember that carbon must have 4 bond. Count it. Kat sini memang 1, 2, 3, 4. Sini pun 1, 2, 3, 4. So this one memang cukup lah, tak perlu tambah hydrogen. Okay. Next, what I'm gonna discuss is actually example I ni. So here is the functional group present. Here is our phenol. Here is our carboxamide. Okay, so actually here I just want to show it to you because the OH is directly bonded to our benzene ring. So you can't do it. The answer here is actually phenol kan. This is phenol. But then it's not here. You have your benzene ring and you have your hydroxyl. But then you know that when the OH is directly bonded to your benzene ring, it's a phenol. So that's why the answer is phenol. Not if you draw it like this. Not yang ni you answer as benzene ring. This as phenol. This is hydroxyl. So that's why it's incorrect lah. This one. The same goes for here. The C double bond O, you thought it will be carbonyl. And then here NH2 is actually your amino. But it's not. It's your C double bond O directly bonded to it is NH2. So what is actually the name, the functional group? Is carboxamide. So here is carboxamide. So that's it. The question for examples on page 6. Okay, on page 7, it's quite a lot. This is actually where you have to draw the functional group that exists. Okay, this is actually that we have in 4.1. Determine the number of primary, secondary, tertiary, quaternary carbon, and primary, secondary, and tertiary hydrogen. Okay, so let's look for example A here. So what we have is actually, okay, it seems quite a lot. What we have is actually this one. We have this is our benzene ring. Okay, here is actually NH2 must be bonded to your carbon. Here is your amino, and here is your carboxylic acid, or the name of the functional group is carboxyl. So if you're unsure, you can check it again based on your notes. So here, it's actually your benzene ring. I'm just going to write down here first. So is it true? NH2 ni amino. So let's check here. NH2. Remember, if the NH2 bonded to C double bond O, it is carboxamide. But if the NH2 is bonded to your carbon, it's an amino. And then this is your carboxylic acid, C double bond OOH. That is the homologous series. The functional group is carboxyl. So we're going to write down carboxyl. Next one is actually to determine the number of primary, secondary carbon, tertiary quaternary carbon, and the hydrogen itself. Okay, so first what we're going to do is actually remember that for the primary, secondary, tertiary quaternary carbon, it's actually only applicable where the carbon has 4 single bond. So if we have 4 single bond, actually benzene ring ni, it's true, it's actually we have our carbon kan, we have our carbon here, but all the carbon ni mesti ada yang bonded to double bond. So it means that the benzene ring cannot be classified. So I'm just going to write down at the side here so that you won't get confused lah. Benzene ring won't get cannot be classified because it is not sp3. sp3 tu yang 4 single bond lah. So just going to write down. Ni sp3 hybridized lah. Okay. So what we have left is actually, okay, so this is actually our carbon. So I'm just going to draw my carbon here. And then here I have my carbon. Sini pun ada carbon. Okay. So from here, okay, this carbon only has 1, 2 bond. So it needs 2 more. 1, 2. Hydrogen, hydrogen. So this carbon only have 1, 2, 3. So it means that it has another 1 more bond. Okay, this carbon, can it be classified? Remember, it needs to be sp3. sp3 tu, the simpler words for it is actually 4 single bond. So this one pun cannot be classified. The benzene ring and the carboxyl. Okay, you don't have to write down the reason for it. It's just that I'm going to write it down so that you won't get confused. Okay, so again, okay, the question asks to determine number of primary carbon, secondary, tertiary, quaternary carbon. So it means that we only have 1, 2 here. So from 1, 2 here, so how to classify it? Okay, this carbon is bonded to 1, 2. So when it's bonded to 2, so what is actually the functional group? The classification. So here is my secondary carbon. So when this is my secondary carbon, so it means that the hydrogen must be secondary hydrogen. Okay, this carbon bonded to 1, 2. Carbon ni pun bonded to 2 of my carbon. So secondary carbon. So here must be my secondary hydrogen. Okay, so how we're gonna answer this? So just gonna write down. So kiranya for primary carbon 0, secondary carbon we have 1, 2. So here we have 2, tertiary none, quaternary none, primary none, primary hydrogen, secondary hydrogen 1, 2, 3. So for the hydrogen, check. Secondary carbon is true, it's 2, but for the hydrogen it's actually 3. So 3, and then tertiary hydrogen is 0. Okay, so just for this example, the rest I believe you could try yourself. This is that here for example B ni, here is actually at the end here is my CH3, right? Here is my CH3. And this carbon actually can be classified because we have 4 single bond. But then this carbon only bonded to what? To oxygen kan? Remember, for the classification, the carbon kalau primary, it means that carbon is bonded to 1 carbon. Okay, this one does not bonded to any carbon. So this one cannot be classified. Okay, so I believe the rest you can try yourself. You're just going to answer the Google form.